Hi, in this video, we will now discuss the next method to solving non-homogeneous differential equation, and this is known as the variation of parameters. So we shall take a look at an example of how we use the variation of parameters first before diving deeper into the theory. So an example of variation of parameters is, okay, so what we do is we want to find a particular solution to the non-homogeneous equation here. We are unable to use the undetermined coefficient as it is a quotient of sine or cosine instead of sum or product. So what happens is that we know that the homogeneous solution is this. To find a particular solution, we just let it be of the form, instead of having constants, we multiply with a function of t. It is something like in the previous few videos where we multiply, we use the reduction of order to help us solve the the second order ODE. But in this case now, what happens is, what we want to do is we multiply t, a function of t, to the fundamental set of solutions for the homogeneous case, and then we solve, we sub it in, and we actually are able to note that we need two equations to solve for this u1 and u2. So what happens is, okay, so we need another equation in order to solve for it. So to get a second equation, we will require the u1 prime cosine t plus the u2 prime sine 2t to equals to 0. Okay, so why is that so? Is because we just let it equal to 0. Then what we get is this y prime equals to this, and the double prime, it will be this. And then we substitute everything in, and our equation simplifies into this equation. Now to solve for u1 and u2, we have two equations. First we have this, and then the next we have this equals to 0. So the understanding is, now we just need to find u1 and u2. We just need to solve this thing. So how we're going to solve this is, we recognize that u2 prime is just equals to minus u1 prime times cosine t sine t, and we substitute that in over here. We're able to get that u1 prime equal to minus 3 cosine t, and so we just integrate normally. What is this? And we see that it will be minus 3 sine t plus c1. As for u2, we just sub in u1 prime as the 3 cosine t, and we get it equals to this. And thus when we integrate this, we get this over here. And recall that our equation and homogeneous solution yc, we use this expression for u1 and u2 to sub it into our equation here, and we get this, because we assume this will be the form of our general solution in the first place, and we see that we are able to solve for the u1 and u2. So this allows us to find the general solution to this homogeneous equation. So the idea is, okay, so we start with this big y, and then we differentiate to get this. And then we looked at it clearly, and we see that we have these terms over here in terms of u prime and u2 prime. So we don't want that, and we want to stick with the u1, u2. So we want this portion to equals to 0. So that's basically the idea behind solving for variation of parameters, and we see that it actually works. So in general, We now want to set our terms involving the u1 prime and the u2 prime to equals to 0. So we just let this equals to 0. And therefore the equation will reduce to the following equation. And what does this show? Well, by doing so, by letting this equal to 0 and reducing it to this is actually looking like this, right? Like it looks like this matrix multiplied by u1 prime and u2 prime and equals to g0. And then how are you going to find the u1 and u2? Well, what can you do for here is you take the inverse of it. And the inverse of this is 1 over this determinant. 1 over that determinant is actually just, the determinant of this is the Weinstein, right? So actually you have a straightaway formula for the following. And you just need to use this, and with this you multiply them together, you get minus gy2 and minus gy2, and the second row is gy1, and you multiply this with the 1 over the Weinstein. So actually u1 is just minus y2 g over Weinstein, and u2 prime is actually y1 over Weinstein, y1 g over Weinstein. And then you just need to integrate to find u1 and u2 respectively. So this is the formula for solving for u1 and u2 without going through the pain of doing all this. So the theorem is that if the function y1 and u2 are the fundamental set of solution, then the homogeneous case, then a particular solution will always be y equals to minus y1 times this plus y2 times this. Why? This is the u1 and this is the u2. And then the general solution will be the following, as indicated earlier. So really there's nothing much to it, and we already see how we get it generally. You can take a look at this example to better understand how to solve for it. And yeah, basically that's it for the variation of parameters. It isn't too hard, and now we understand it to a deeper level by seeing it in the general sense. So I hope you have enjoyed this video. This is a short one, and I'll catch you again. Bye.